Hi, in this video, I'm going to explain to you some special characteristic of a cumulative distribution function. Alright, this is a cumulative distribution function for a continuous random variable. Right. In this video, I'm going to explain just one or two characteristic of cumulative function that you must know. Alright. So the first is you must observe that there is some special thing that you must see is that you look at the value here, right? -2 is 0, right? -2 is 0. So when there is -2, you substitute here, right? You substitute the -2 here. 2 minus with 2 over 10, you are still getting 0. Means that the value before go to this for this value is is 0, and -2 if you substitute here, you're getting 0 also. Alright, it's the same thing also when you substitute 0 here. Okay, you have to listen to this. You substitute 0 here, 2 over 10, right? 2 over 10. So you are getting 1 over 5, right? You're getting 1 over 5. So, but if you substitute the 0 into this function here, you are still getting the same value, you know. Alright, you substitute 0 here. So 1 over 5, you're also getting 1 over 5. Right, you're also getting 1 over 5. So now, if I substitute the 2, before, after, you're getting the same value. Alright, you're getting 1 over 5. Here you're getting 1 over 5. Here also you're getting 1 over 5. So if 2, right, if you substitute the 2 here, 2 plus 1. 2 plus 1 is 3. So you're getting 3 over 5. Then you try, you substitute this 2 here. There is no x here, right? So it will be taken as 3 over 5 also. Can you see that? Before, after is the same. Alright? Okay, you try 7, right? 7. It's also 3 over 5. It's also 3 over 5. So 7, also 3 over 5. So you look at the 7 here. If you put 7 here, 7 plus 5, right? You say 7 plus 5 over with 20 is 12 over 20. You are still getting 3 over 5, right? This is the special thing that I want to tell you. Alright, it's easy, but you have to remember, if this is a cumulative distribution function, the value before and value after the interval, right? You see, you have the same value, right? 0, you substitute -2 here, you're getting 0. So you substitute 0 here, you're getting 2 over 10, which is 1 over 5. And you substitute the 0 here also, you are still getting 1 over 5. Alright, you substitute 2 here, you're getting 3 over 5. 2 here, you're getting 3 over 5. Can you see that? They are the same, right? You see 7, so 3 over 5. So when you substitute here, 7 plus 5 over with 20, right? 7 plus 5 over 20. You are getting 3 over 5 also. Same thing also if you substitute 15 here. If you substitute 15, 15 plus 5, you have 20 over 20, which gives you 1, right? And here also, 15, you're getting 1. That is the first thing that you must know, right? They have the same value, right? They have the same value before and after. Alright, so now I'm going to sketch the graph for you and let you see why is this happen. Alright, now I'm going to sketch the just now I have explained the characteristic here. Alright, so now I'm going to sketch the graph. The graph for cumulative distribution function, they are continuous. Alright, then you see the meaning here. So alright, I'm sketching here. Alright, okay, let's see how I'm sketching the graph of cumulative distribution function. So before -2, right? Before -2, so it will be 0, right? Fx will be equals to 0, right? Before -2. So there's an empty circle here. So before 0, it will be Fx equals to 0. Right, from -2 up to 0 is a linear function, right? It's a linear function. So you can just use the boundary value to finding the 2 point and sketching the line. Alright, okay, you substitute -2 here, right? You substitute -2 here. You can find out it also will be 0, right? You substitute, you're getting 0. Here also you were getting 0. So definitely during -2, you are still 0. But this is already, you see that? Equal, right? So you substitute -2, 2 minus 2, 0 over 10, then you get 0. So how about 0, right? Substitute 0, you're getting 1 over 5, right? 1 over 5. So it's maybe I can put the 1 over 5 here, right? 1 over 5. So -2, then here will be 1 over 5, right? Empty circle, right? So 0, 105. So you draw, there's a straight line here, right? There is a straight line here. Later on, we see the next interval here from 0 up to 2, right? From 0 up to 2. So you substitute the 0 again. You will find out that the value here, when you substitute the 0, you were still getting 1 over 5, right? Because just now you're getting 1 over 5 also, right? So now include equal, right? Equal. So you substitute getting 0. So this circle will be filled in, right? Will fill the EC, alright? So 0. So then 2, right? You find out 2. You substitute the value of 2, you see? 2 plus 1, 305, right? So during 2, it will be at 305. 2 over 5, 3 over 5, alright? 2 over 5, 3 over 5. So during 2, it will be 3 over 5. So I put an empty circle here, right? So you put 2, 2 plus 1, 3 over 5. So they are no equal. So now I draw again, right? It's also a straight line, right? It's also a straight line. So now we look at 2 to 7, right? Now it's 2 to 7. You put 2, you're getting 2 plus 1 over 5, you're getting 3 over 5, right? You see, when you see that when the x equals to 2, the value is also 3 over 5. So it's also 3 over 5. So they will join back, right? They will join back. So, and when 7, right? When 7 is also 3 over 5, right? Means that it's a horizontal line. From 2 to 7 is a horizontal line. From 2 to 7, alright? From 2 to 7, it is a horizontal line, right? It's a horizontal line. So if you look at it, 2 to 7, 3 over 5. Later on, 7 is 3 over 5. When you put 7 here, 7 plus 5 is 12. 12 over 20. 12 over 20 is 3 over 5 also, right? 3 over 5. So, and this hole will be filled in again, right? So later on, 15, right? 15 plus 5. 15 plus 5 will be 20 over 20. So means that 14, 15, right? During 15, it will be reaching 1. This is cumulative, right? Cumulative. 1 over 5, 2 over 5, 3 over 5, 4 over 5, 5 over 5, 1. So means that at last, it will be 15, it will be at 1, right? It will be at 1. So means that this is a straight line also, right? It's a straight line. If you see that, 7 to 15 is a straight line. So during 15, you're getting 1, right? Then after that, include the 15. After 15, also 1, right? So means that after this is filled in, so it will be 1, the value of 1, right? The value of 1. So if you look at the graph for cumulative, it's different from probability density function. It's different because it will start with 0, ending with 1, right? Ending with 1. And along the graph here, there will be always continuous. They were joining, can you see? They will join, alright? They will join. So that's why what I want to explain about the characteristic here is, if you put the negative 2, you're getting 0. Negative 2, you're getting 0 because they're sharing the same point. So for this one also, if you substitute 0, you're getting 1 over 5, right? You substitute 0, you're getting 1 over 5. And the substitute 0 here is also getting 1 over 5. So they're also sharing the same point, right? So you have to remember this. Later, there were some question will tested you this concept here. But this is only true when this is a cumulative distribution function for continuous random variable. Okay? Then now you can observe that the graph. Okay? The graph will be increasing until from 0 up to 1. Alright? Okay, now in the same video, I'm going to teach you how to find the median, the third quartile and first quartile by using this function here, cumulative distribution function. Alright, okay, let's see how to finding the median from this distribution. Alright, by using cumulative distribution function for continuous random variable. Right, the way of finding median is very simple. Alright, so you look at the value here, you have 0, right? Yeah, you just look at if you want to find median, third quartile and first quartile or percentile, we look at the upper value, right? The value that you substitute here, then what is the value, right? Observe. So when you put 0 here, you're getting 1 over 5, right? You're getting 1 over 5. So when you substitute 2, you're getting 3 over 5, right? 3 over 5. So when you substitute 7, you're still getting 3 over 5. So you're getting 1, and this is also 1, right? So which is the first value? Okay, for median is defined to be the cumulative, alright? Or we say that px less or equal m equals to half, 0.5, right? Or half, right? 0.5. So if you see all the value here, this is 0, this is 0.2, right? This is 0.6. This is also 0.6, this is 1, right? So definitely it will not be in the first and the first cumulative distribution function, 0 and 1. It will not be here, right? For the median, it will be in somewhere around here, right? So this is also will not be here, because why? This is 0.2. It's just 0.2. 0.2 is less than 0.5. Right, less than 0.5, so it will not be here, right? It will not be here. So here you have 0.6 and 0.6 have the same value, but which one is the first 0.6? This one, right? This is the second 0. So this one is the first value that more than 0.5, right? This is more than 0.5. So this one is less than 0.5. So if this value is the value when you substitute, you're getting more than 0.5, then the m, the median, will be here, right? Then the median will be around 0 to 2. Okay? It's around 0 to 2. So then, of course, you have to select a correct function to substitute the m. So now in this case, the m is here, so you substitute the m into here. So you're getting m plus 1 over with 5 equals to the value of 1 over 2. Right, very simple. So means that the m plus 1 will be 5 over 2, 5 over 2, 5 over 2 is 2.5, right? 5 over 2, 2.5. Then the m, the median, will be 2.5 minus with 1, which is 1.5, right? You see that the value of m is 1.5, which is in between 0 and 2. So this will be your median, right? This will be your median of this distribution. Alright, okay, I extend a bit so that you have more examples. Okay, so what if the question asking us to find the first quartile, right? The first quartile. So the first quartile is also the same. The first quartile is defined to be FQ1, right? So which is equals to probability of X before Q1, or we say that it to be 1 over 4 or 0.25, right? 0.25. So again, okay, you look at the value here, right? We look at the value here. Right, okay, let's see. So you look at all this value here, right? Okay, all this value. This is 0.2, right? 0.2. This is 0.25. It's still less than. This is not more than 0.25. So okay, definitely it will not at the first and the last one, right? It also will not be here. The reason is why this is 0.2 only. This is 0.25, right? It's less than 0.25, right? So, and this is the value that there are 2, 3, or 5 here. This is the first value that more than 0.5. So means that the quartile and the median will be in the same range, right? Same range. So means that the Q1 you have to substitute here also. Same thing here, alright? It's applied the same. Q1 plus 1 over with 5 equals to 1 over 4, alright? So substitute this Q1 into a correct function, alright? How to choose the correct function is you must observe the value here, alright? You must observe the value here. So, okay, 105, so Q1 plus 1 will be equals to 5 over 4, right? 5 over 4. 5 over 4 is 1.25, right? 1.25. So means that your first quartile will be 1.25 minus 1, which is 0.25, right? 0.25. And 0.25 is between this, right? Between the range, right? In between the range. And the median also 1.5, right? Is within the range. So definitely the first quartile will be less than the median, right? Okay, how to find the third quartile, right? How to find the third quartile? All right, so I'm just writing here so that you're able to understand. Okay, I already give quite some example for all this, all right? Because it's very important, so I keep repeating. So if this is a third quartile is defined to be FQ3, Px less or equal Q3, which is 3 over 4. 3 over 4 is 0.75. Right, 0.75. Okay, let's look at this again. Right, look at this again. This is 0.75. Definitely, first it will not at the first and the last one. Okay, it will not be here because this is 0.2. It also will not be here. Do you know why? Median is here, first quartile is here, but third quartile is not here because this is just 0.6. 0.6. This one is 0.75. No, it's less than. This one is also 0.6. Means that the third quartile also will not be here. Alright, will not be here. But there is 2, 1 here, right? So this is the first one that more than 0.75. Alright, more than 0.75. All this is less than 0.75. So the third quartile must be here. Right, the third quartile must be here. So means that your value of Q3 have to put into the correct function. Alright, by observe all this value here. So okay, how to do this? So you can put the Q3 into Q3 plus 5 over with 20, right? This one. So Q3 is within here, so which is equals to 3 over 4. So then you calculate, easily you can get your third quartile. So 3 over 4 times with 20, right? 4, 5, 20, 3, 5, 15, right? So from here you can see that your third quartile will be 15 minus 5, right? 15 minus 5, which give you the value of 10, right? Yes, 10 is within 7 and 15. So it means that this is accurate, right? So the 10 here is the third quartile and the first quartile is 0.2, is 0.25 and the median is 1.5. Alright, okay, this is the way we're finding the... Okay, first in this video I introduce you what is the characteristic of this, right? The value before and after, they have the same value, right? Okay, secondly, I teach you how to sketch the graph for cumulative distribution function. Can you observe the graph? The graph is continuous. It starts with 0 and end with 1. And along the graph, there are no hole. Everything is connected, alright? Okay, then if you look at this, you can how to find the median, the first quartile, third quartile by using the cumulative, right? Okay, and in the next video, for the same examples here, I'm going to show you how to find the probability density function. Means that I want to teach you how to go back, right? This is cumulative, how to back to the probability density function, right? Previously, we have teach you how to from the density function to the cumulative. Now I'm going to teach you how to move from the probability the cumulative distribution function back to the probability density function. Okay, but it will be another video. Right, see you.